The overall goal of this laboratory method is to produce biofuels and biochemicals from co-processing of canola oil with fossil-based feeds.
This method can help answer key questions in chemical engineering relating to catalytic cracking of heavy oils, fuel chemistry, catalysis, and reaction mechanisms.
The main advantage of this technique is that the method is fast and cost-effective, enabling full control over the test parameters and the reduction of human error.
The implications of this technique extend towards catalyst development, as the equipment used is simple, reliable, and productive for testing new formulas.
Although this study focuses on product distribution and quality, the method can also be applied to other fields such as predictive modeling and simulations.
I'm pleased to introduce my teammates, research scientist Nicole Heshka, Zhang, and R&D program advisor Evelito. They will demonstrate the procedure and/or discuss the method.
To begin this procedure, disconnect the oil feed line below the purge valve of a laboratory test unit, or LTU, and attach a short temporary tube to the bottom of the valve. Following this, preheat a previously prepared feedstock to 85 degrees Celsius to enable the heavy gas oil, or HGO, blend to flow easily. Place a tiered beaker at the discharge of the short temporary tube connected to the oil feed pump. Then, start the preset PumpCal user program in the reaction unit software. After the PumpCal program is complete, remove and weigh the beaker containing the feed. Divide the mass of the feed delivered into the beaker.